Hello everyone. So in this video we are going to solve the problem related to the collar, and this problem is from the kinetics of the particle, and we use the principle of conservation of energy to solve the problem related to collar. Okay, so the question has said, so let us begin from the question. uh, so the question has said that a 500-gram collar of 500-gram collar can slide without friction on the cork rod BC. Cork rod BC in a horizontal plane. Okay, the most important thing that we have to consider while solving this type of problem is that whether the collar is sliding in the horizontal plane or in the vertical plane. So the question has said that the uh, collar is sliding in the horizontal plane. Okay, so knowing that the undeformed length of the spring is 80 mm, the undeformed length of the spring is given as 80 mm, and the value of the spring constant K is given as 400 kilonewton per meter. So the question has asked us to determine the velocity that the collars should be given at A. When the collar is at A, the velocity should we give to the collar so that it reaches to the position B with zero velocity. Okay, so the question has said that at the position what velocity that we should provide to the position A, so that when the collar reaches the position B, the velocity becomes 0. So likewise in the second part, the question has asked us to determine the velocity of the collar when it eventually reaches C. So that when the collar reaches at the position C, what will be the velocity of the collar? The question has asked us to determine it. So let us begin. Okay, so at position A, the kinetic energy is given as 1 by 2 mva square equals to 1 by 2 into m. Mass of the collar is given as, where m stands for the mass of the collar. Okay, the mass of the collar is given as 500 gram, which is equals to 0.5 kg into ba square. We don't know the velocity of the ba velocity at position A, so we need to calculate it. Okay, and we obtain the result as 0.25 into ba square. So the extension, so also the another thing, the question has given data as the undeformed length of the spring is 80 mm. So before the collar is attached on the slider, the undeformed length of the spring was 80 mm. Okay, so now the extension produced, so the extended length when the collar is at position A is equals to 150 mm. So the extended length when the collar is at position A is equals to the 150 mm. So the extension produced can be calculated as using the formula extended length minus undeformed length of the spring. So the extended length of the spring is given as 150 mm, and the undeformed length is given as 80 mm. So the total extension produced is equals to 70 mm, which is equals to 0.07 meter. Okay, so let our datum be at position A. So let us suppose that our datum means the reference point. Reference point is at the position A. Okay, so the potential energy at A is given as, so we can calculate the, so the potential energy at the position A is given as sum of the potential energy due to gravity and potential energy due to spring. But the potential energy due to gravity at the position A is equals to 0. Why the potential energy due to gravity at the position A is 0? Because the collar is sliding in the horizontal plane, not in vertical plane. Okay, if the collar is as you know that the potential energy due to gravity is equals to mgs, product of mass into acceleration due to gravity into height. Okay, so if the collar is sliding in the horizontal plane, there is no value of h. So when the value of h is equals to 0, the potential energy due to gravity also becomes 0. But if the collar is sliding in the vertical plane, okay, if the collar is sliding in the vertical plane, then there will be definitely some value of h. Okay, so if the collar are sliding in the vertical plane, there will be some value of the potential energy. But in this case the collar is sliding in the horizontal plane. In the horizontal plane there is no value of h, so due to this reason the potential energy due to gravity of the collar becomes 0. So potential energy at position A is equals to the sum of the potential energy due to gravity plus spring. So the value of the potential energy due to gravity is equals to 0, and the potential energy of the spring is given as 1 by 2 kx square. So but the k means the spring constant and x1 is the extension produced. So the value of k is given as 400 into 10 to the power 3, and the value of x1 is given as 0.07 meter. And substituting these values on this equation, we get the potential energy at position A as 980 joule. Likewise, so the one of the most important thing while solving this type of problem is that we have to consider that in a horizontal plane the potential energy due to gravity is always 0. Okay, since the question has said that there is 0 velocity at position B, so at position B the velocity at the position B is equals to 0, so the kinetic energy at the position B also becomes equals to 0. So at position B extension x2 is given as external length minus undeformed length. So the external length at the position A from the datum, okay, let us draw the datum here. So from this datum to this position B, the external length of the spring is equals to, so the external length of the spring when the collar is at the position B is equals to 200 mm. So the extension produced is equals to external length minus undeformed length. The value of the undeformed length is given as 80 mm. Okay, so on subtracting them 0.2 meter minus 0.08 meter, we get the we calculate the extension as 0.120 meter. So the potential energy at position B is equals to 1 by 2 kx2 square, which is equals to 1 by 2 400 into 10 to the power 3 into 0.120 square, which is equals to 2880. So here in this at position B also we have neglected the potential energy due to gravity. So here also we have neglected the potential energy due to gravity. So we have calculated the potential energy on the collar only due to spring. Okay, so the system is isolated system. Okay, the problem, this problem is this collar problem is done on the isolated system. So we can, when the system is the isolated system, we can use the principle of conservation of energy. So so the question has asked us to find out the at first part the question has asked us to find out the velocity at the position A, the velocity of the collar that must be given at the when the collar is at position A. So for this we apply the principle of conservation of energy, that is kinetic energy at position A plus potential energy at position A equals to kinetic energy at position B plus potential energy at position B. Okay, so on solving we substitute the value of TA as equals to 0.25 into BA square plus the value of BA is obtained as 980 equals to potential kinetic, the value of kinetic energy at position B is equals to 0 and the value of BB is equals to 2880, and on solving we get the value of the BA as equals to 87.17 meter per second. So likewise in the part B the question has asked us to find out the velocity of the collar when it eventually reaches at C. Okay, so at position C the kinetic energy is given as Tc equals to 1 by 2 mbc square. So the value of m is equals to 0.5, but we don't know the value of the bc, so we keep it as bc, so we obtain the result as 0.25 bc square. So likewise we have to again calculate the extension produced when the collar is at position C. So the extension of the spring from this reference point when the collar is at the position C is equals to extended length is equals to 100 mm. So but undeformed length is 80 mm. So okay, so for the extension we subtract 100 mm minus 80 mm, and 100 mm is equals to 0.1 meter and 80 mm is equals to 0.08 meter. So we obtain the extension as 0.02 meter. Okay, So the potential energy at position C is given as Bc equals to 1 by 2 kx3 square. So here also we have neglected the value potential energy due to the gravity, because the collar is sliding in the horizontal plane. So on substituting the value of the x3, which is equals to 0.02, so we can find out the potential energy at the position C as 80 joule. So now using, so from principle of conservation of energy, we can write the equation as kinetic energy at position B, kinetic and potential energy at position B equals to sum of kinetic energy and potential energy at position C. So the kinetic energy, so we can either use TA plus BA equals to TC plus BC, or we can use TB plus BB equals to TC plus BC. Both method will be correct. Okay, so for easiness we will use TB and the value of TB and BB. So the value of TB is obtained as 0. Okay, the value of TB is obtained as 0. We have calculated the value of TB as 0. The potential energy at position B is equals to 2880. Likewise, the kinetic energy at position C is obtained as 0.25 Bc square. So the potential energy at the position C is obtained as 0.25 Bc square as our kinetic energy, and the potential energy at position C is we have calculated it as 80 joule. So substituting all this above value in this equation and calculating on calculator, we can get the value of the velocity of the collar at C as 105.833 meter per second. Okay, so the problem at the beginning, the problem looked quite complicated, but the problem is not that much complicated as we think. But we have to be careful only on the one thing. The most important thing that we have to be careful is that whether the collar is sliding in the horizontal plane or vertical plane. If the collar is sliding in the vertical plane, the potential energy due to gravity is going to become 0. If the collar is sliding in the vertical plane, then there will be the some value of the potential energy due to gravity. Okay, so thank you.